Hi, so today's topic scattering parameter, and I am going to complete about session 8. That means we are discuss about the session 8, which is scattering parameters. So for that, aim of the session is to concept and understood the scattering parameter, and we will demonstrate here the about a two-port network, describe about S parameter, and we will describe the case of S parameters. And the session outcome is how effective is the S parameter for two-port network at microwave frequency. That is most important terms. So if you are thinking about S parameter, the practical system characterization can no longer be accomplished through the simple open or short circuit measurements. So if it is thinking about the low frequency application, but if you are thinking about the wave propagation, so it is not desirable to introduce a reflection coefficient whose magnitude is unity. For example, the terminal discontinuity will cause undesirable voltage and or current wave reflections, leading to oscillation that can result in destruction of the device. Using S parameter, the RF engineer has a tool to characterize the two-port network without causing harm to the device under test. So if you are going for S parameter, we are thinking about S11, S22, S12, S21. Now we can see A1. So this is a forwarding wave, and A2, it is the reverse wave. Like that, if you are thinking about B1, it is forwarding and it is forwarded from the, it is reverse from the port 1, and this one is reverse from the port 2. So always we are thinking about A1, A2, B1 and B2. So if you are thinking about incident normalized and reflector normalized, then incident normalized are these two and reflected normalized are these two. So if you are thinking about this, then the power equation N equal to 1 by 2 Z, Z0 is your characteristic impedance, and Vn, that means voltage, N is the either port number 1 or 2, Z0 I1. So these two are the equation to find out the incident normalized power wave or reflected. This one is reflected one, this one is the incident one. Now if you are thinking about this and imagine where the input or output impedance are same, then inverting leads to following voltage. So if we minimize that equations, then we will get Vn equal to this, In equal to this, if we follow this situation or condition. Then from that we can find out N equal to this much or this much, or Bn equal to this or this. So from that we can find out this one, and then we will rewrite the equation. After, from the definition we know total voltage at any node is equal to forwarding voltage plus reflecting voltage, and voltage is equal to, always know, V equal to IR, but in this case we can write I into Z because we are thinking about the impedance. So Z0 into In plus minus Z0 In minus. What is In plus? It is the forwarding current, and In minus is the reverse current. So if we segregate all the things, then it can be written as B1, B2, that means it is the reflecting wave is equal to S11, S12, S21, S22 and A1, B1. This is most important equation. So from that, how will find out S11? When we are taking A2 equal to 0, that time we are getting S11 and that value is B1 by A1. So B1 is the reflected power wave at port 1, A1 is incident power wave at port 1. Then if you are thinking about S2, then make S21, then make A2 equal to 0. So if you will make A2 equal to 0, B2 by A1. So B2 is equal to transmitted power wave at port 2 by incident power wave at port 1. So for S22, if you are thinking, you have to take A1 equal to 0, so then it is B1 by A2, and it is reflected as reflected power wave at port 2 by incident power wave at port 2. So if you are thinking about S12, then it is B1 by A2, A1 is equal to 0, and it is transmitted power wave at port 1 by incident power wave at port 2. When A2 equal to 0 and A1 equal to 0 represents that no power waves are returned to the network at either port 2 or port 1. It can only be achieved when the connecting transmission lines are terminated into their characteristic impedance. Now if you are thinking about S parameter related to power, then we need to calculate the average power at port 1. So it is equal to half of V1 plus means forwarding power square by Z0 this much. I am not going for derivation, total derivation. I am just extracting some values from there. Is equal to this much 1 by S11 square. Gamma in square also we can write it is S11 square. So what is gamma in? Is the reflection coefficient, input reflection coefficient. So now from that we can find out the gamma in equal to V in plus by V in plus means small v in is small v in plus. So it is S11. So the VSWR always we know is equal to 1 plus S11 by 1 minus S11. So from that if we will find out the incident power, thus incident power equal to this equal to A1 square by 2. And if we are getting the reflective power and we are getting the incident power, if we want the total power, then is equal to this much. And if we are thinking about the reverse one, if you put in case of reflection coefficient S11 is 0, all available power from the source is delivered to the port 1 of the network, and in identical analysis at port 2 we can think about and we can get the same thing, but here it is gamma in, here we can find out gamma out, here we are A1, here we are thinking about A2, and here A1, here also A2, and B1 it is B2 it will come, and instead of P1 we need to write P2. So this is the two power thinking. We are taking incident power and reflected power. So if you are thinking about the record S1 and S21, we have to ensure that on the output side the line impedance Z0 is matched, or for A2 equal to 0 must be ensured. So here I am matching the circuit by taking the load impedance. This side I have given a voltage. If this is matter, then we can write that S1n equal to gamma in is equal to Z in minus Z0 by Z in plus Z0. And from that the reflection mechanism return loss RL is equal to this much we can find out, and S1n equal to this. So we can find out by putting the values. If I am thinking about since A2 equal to 0, then S21 equal to 2V2 minus Vg by Vg1 is equal to this much. So G0 is the forward gain is equal to S21 square is equal to this much. I am not going for total derivation. Now if you are thinking about the reverse case, we are giving voltage here and getting the load resistance this side and perfectly match, then we can find out S22 and S12. So for that we are similar process we will go for, and we will get S22 equal to gamma out equal to Z out minus Z0 by Z out plus Z0, S12 equal to this much, and S12 this much. If we will make Vg minus V2 will replace because total value is equal to V2 only, so S12 equal to this much. Now from this we conclude that S11 and S22 can be directly computed as part of impedance definition, and S12 and S21 require the replacement of the defining voltage by the approximate network parameter. So we can think about two things, one this side, one is that side. Okay. So whatever the questions, self-assessment questions I have given like this, and these are the 1 minute I am showing you. These are the terminal questions, the reference books, and thank you. This is the end of 8th session.